Hey everyone, wait a minute. I'm on the wrong laptop. I'll just switch real quick. Oh, I was muted. Sorry. Okay, so this is Vishal Lokare. I welcome you all to the day one session. Today we'll be doing track one, module one, and module two. So, yeah, let's just get started. Is my screen visible? Just one yes will be enough. Yeah, okay. So, so today's session agenda will be first, I'll show you what modules are we going to cover today. Then some things that you have to keep in mind. Then I'll talk about career in Google Cloud. I will talk like more about the infrastructure part of the Google Cloud. Then from the module two, there is GCP compute, storage, and IAM rules that we'll be going to look at. And then at the end, I'll show you again like what modules that we are covering today. Okay, so this is session one, day one, track one, module one, and module two. Okay, so some important information first that make sure if you can, and it's recommended that you open Quick Labs every time in incognito mode because whenever you open a lab and like Google tries to sign in with the already signed in accounts. So let's say you have your personal account, it will try to sign in with Google. It will try to sign in into Quick Labs with that account. So yeah, that will not happen in incognito mode. So it's better to always use incognito mode. Plus, you just have to sign in once, and then in each lab, like you would have done a two lab by now, in which you would have got a bit familiar with the Quick Labs platform. Then next is, yeah, whenever you start any lab, make sure that you have enough time to complete it with full concentration because every step is important. And whatever you read in the lab, you have to execute on the GCP platform. So always make sure that how much ever time the lab is showing, like let's say it shows 1 hour. So make sure that you have at least 45 minutes free time and you can concentrate on the lab. And yeah, initially every lab has a limit of 5. So let's say you start the first lab and you have to cut off in between. Then you start once more. And if you do this 5 times, the limit will be exhausted. But uh, in like just in case if you need to extend the limit, there is a way you can just contact me or you can contact QuickLab support and tell them that I just need some extra limit. So they will reset it to 0, and then you will again have a limit of 5. So that way you can get more limit for the labs. Okay, and currently like some students might have an expiry date of like 24 or 20 October. So in case if you need an extra monthly pass, it will be provided later. So don't worry that your Quick Labs monthly subscription is ending before October 27th. It will be made sure that you complete all the labs before that. And again, yeah, attending classes is not actually compulsory. We are just going to look at theoretical aspects of Google Cloud Platform and only the infrastructure part. So I'm just going to brief you off with what Google Cloud is and how can you make use of it, and not the actual practical steps because that a student has to perform on their own. Okay, so where are we? We are currently at day one. Today is like week one, Friday. As I said, Sundays will be like blocked for now. We don't have any planned classes on Sundays. But if you guys have some practical doubts too, we can cover that on Sunday. Like we can have a small session with only those people who have doubt, and you can just come and clear it. Or you can clear it anytime, even after the sessions. You can just drop me a message on WhatsApp or Discord. So yeah, today's track one. We will be covering the first two modules. So the first module is getting started. We create and manage some cloud resources. Second is we perform some foundational infrastructure tasks. Again, like every lab is very well defined. So even if you follow whatever is given in the lab, you will have a practical knowledge and experience in how to execute those steps in the future. And again, we will cover the theoretical part in these sessions on the Friday and Saturday sessions. So you don't need to worry about missing out on something. Okay, so what's like cloud anyway? So cloud carriers are actually very much in demand because any like every company needs some sort of database and structure. Like every company needs a backend where every data is stored and a lot of functions will be stored in the backend. Just a second. Yeah, so every company needs a backend where like every data will be stored and it will have a lot of functions that will be executed. So that hence like there is a lot of demand for cloud computing too. There are actually statistics that okay. So like there was a survey done and nearly like 80% of the people who are hired are not actually much skilled enough to perform every task uh, which has to be done by the company. So this is actually a very good field if you want to take it as a career. You can like help a lot of companies build their backend servers and stuff. Yeah, and there are also some Google Cloud certifications. Like you would have heard even certifications from other cloud platforms. So Google Cloud also provides these. As I said, like each certification just certifies that you have enough skill to do it. And it's also valued a lot while hiring. So if you show these, it does mean that you actually know what you know and not just a certificate. So yeah, starting off with like cloud. So uh, if you see Google Cloud, there's like uh, it is made uh, by keeping in mind of what a customer would need. Okay, so first, you have like an on-demand service. So whenever you need anything, like let's say you need a VM, you just make an account, add a billing account, and you just reserve a VM, which will be just for you. You can turn it on anytime, you can turn it off anytime, you can do whatever you want inside the VM. VM is a virtual machine, and yeah, that's it. Then Google Cloud has like a very broad network throughout the world. Like in the next slide, I'll even show you like how the lines, like all the broadband lines of Google Cloud are laid out through over the world. Then resource pooling is like you will be sharing those resources with other people too, which from the Google Cloud farms. So there are these big farms where there are huge buildings inside which every server, like all the servers and everything of the backend will be kept. And whenever you reserve a VM, it will be reserved from that region, whichever you select. So resource pooling is like to bring down the cost. Okay, let's take an example. Like if you are a company and you have to mm, like buy servers, like you have decided to go for an in-house server where the company will buy the server and manage it fully. So there are a lot of tasks. It's like where do we keep the servers and which network do we connect it to because we need to get good pings and like good access from all over the world. Then you have to even take care of security that no one is able to crack into it or something. So Google Cloud manages all of this. As I said, like there are these big farms where Google Cloud has a lot of servers, and you can just reserve your small share from it, and it will be beneficial for both the parties, the Google Cloud because they have like a lot of computers together, and for you as well because you don't have to buy servers and keep managing it and hire more people to manage it. Then yeah, so whenever like you want more resources, you can just scale up anytime. So let's say right now you have like 100 GB of storage and you want 200 GB. So you can just add an extra 100 within a few minutes by just going to the Google Cloud Console. And in all terms, not just in terms of storage, let's say you need more computing power, you can do that as well, because like Google Cloud has you covered in that sense. Then again, cost is less, so it's beneficial for both. Yeah, and nowadays, like every company is a data company, so every company needs to store some data somewhere. Okay, now even if you take like non-tech related companies, they need to store some data of their employees, of their customers, okay, and some internal confidential files or something. So they can just take use of Google Cloud as well. Yeah, next, we like you would have heard of these terms like IEA, IEAS, then PaaS and SaaS. So SaaS you would have heard more often. It's called Software as a Service. So starting from IEAS, it's short for Infrastructure as a Service, in which the service is the infrastructure. So you will be only provided like computing power, memories, storage, and like a laid out network which can be accessed from anywhere. But the user who has taken that service has to manage everything else. So they have to like manage the security too. They have to put in their functions. They have to put in like basically everything else. The infrastructure is just like giving hardware as a service. So there's no software, like not much of a software involved. And then there is like platform as a service where you get everything of infrastructure, plus you'll get some more like managed sort of a service where Google Cloud will manage some services on your behalf. Okay, and software is just like where where the party is giving you a software. So let's say I need to make an app and I go to like Aditya. So like, hey Aditya, I want this app done, and Aditya gives me a software. So that will come under software as a service. It does not involve any sort of hardware or any sort of infrastructure or a managed service. Okay, so this is it. Yeah. As you can see, like Google Cloud has a very good network laid out throughout the world. You can see like these are actual you call it subsea lines, which are like under the water, and these are all connected. These are like the actual lines over the world. You can see like there's one country not there in the picture. So like I don't know the reason for that, but you can find it out. I just let this slide be so you can all watch it. Okay, so to share like one more relatable example that you can think of. So going back to the previous slide, infrastructure, like it in the month of April, Aditya and I participated in like some hackathons, and we wanted some servers that should be running like all the time, because we don't know when the judges will check our website or application. So we didn't want any like part of downtime in the service. So what we did was we just went ahead with GCP and we created a VM which was based on Ubuntu OS, and then we just like transferred our application to it, and it was like running 24 hours. So we don't have to worry about who is accessing our application from where, and we don't have to worry about the downtime that will get. Because if we were to host it on a laptop, like we will have to shut it down sometime. So yeah, so this will actually come under infrastructure because we have only taken some part of computing power, some part of storage, and some memory. And we are putting in the software in the VM. Okay, now platform is a bit more like sort of complicated where you will have some more levels to it. Okay, now going ahead. Um, yeah, so these are the top five category service that Google Cloud provides. So first is compute engine. It has like all the VMs and stuff. Second is like Google Kubernetes engine. Kubernetes is now open source and you can just search it up what it is. Then there is App Engine. There are Cloud Functions. There is Cloud Run. So you can just search about all these. These all will be covered in your Quick Labs too. So you will get an hands-on experience on how to make clusters in Kubernetes and how to like uh, use all of these services. So yeah, in terms of storage, Google Cloud also provides you like these five categories. So cloud storage, you can think of it's just normal storage that you have, like the pen drive and hard disks, in which you can store any kind of file. It can be a photo, it can be a video, it can be basically anything. Cloud SQL, like currently we are having a course. BAS 2020 has a course called Database Management Systems, in which uh, actually, wait, it was last semester. We learned about SQL and we uh, like learned how to write SQL queries and stuff. So we know that SQL is a relational database in which there are tables, there are like columns and rows. So Cloud SQL is that. It's actually a mixture of PostgreSQL and one more. I can't recall it now. You can search it up. Then you can search like about all of these too. Yeah, so there's like Google Cloud also covers you in terms of like big data and machine learning. So this is actually from track two, but I've just listed them down here. I will cover these in tomorrow's session actually, but I just wanted to show you the names of the services that Google Cloud provides. So there's like BigQuery, there are PubSubs, there's Dataflow, Dataproc, AI platform notebooks. Then on the machine learning side, there is AI platform, Vision API, speech to text, also text to speech, then cloud translation, AutoML. Actually, Vision API and speech to text, like these APIs, you can actually use a lot even in your personal projects. So GCP is not just for like big companies to host their backend. This is also for small projects. Like as I said, in the month of April, we used this for hosting our backend, and we used it like three times. We had like three hackathons, and we used like a separate VM according to the need. And coming to projects, like there's also one more project which is currently live, like it's working. It's called AutoJoomer, and it's also hosted on GCP. So, like the backend of AutoJoomer, it's an open source project handled by like five contributors now. It's for the batch 2020 currently, in which you can join classes without having to remember which class is going on. So the backend of this, like all the links, all the class names are kept in Firebase, which is also a product of GCP, which is totally linked with GCP. So that's it. So I just wanted to say like it's not necessary that you have to be a big company or like someone big to use GCP. You can use it for your personal projects as well. Okay, now coming to module two. Like this was module one till now, and you can like do these labs after the session, or like some of you might already have. So this starts with module two. In this, we'll cover three things like compute, storage, and IAM roles. Okay, so compute engine, if we see, and I have mentioned this like quite a time now that it gives you virtual machines which you can create and run. You don't need to worry about what if it gets turned off or something. It's like very highly reliable. You can totally rely onto GCP while hosting your virtual machines and the backend of your project. Then let's start one by one from the circle. So you get like general purpose and optimized VMs. Then you can also customize the machine types. So if you have used VM, like if you have made a VM till now, you would see that there are some certain limitations while creating VM. That if you need two virtual cores, you have to like go ahead with some 512 MB RAM. And then if you need just more computing power, your RAM increases as well. So you don't have like a middle place where you can only increase compute or RAM. So Google Cloud has that as well. You can only increase computing power or only increase memory as per your need. Okay, then there is right sizing recommendation. So this is when you start using your VM and GCP detects that in like in 2 to 3 days that you are using more than what you should do. So let's say you have made a backend for like 1 lakh of people, but only 1,000 of them are being used, and you didn't know that only 1,000 is sufficient for a project. So Google Cloud will just remind you that you are using more storage. You can just shift to a lower storage and reduce a billing cost. And also there are these recommendations to these recommendations vary from like turning off your VM. So if your VM has been inactive for too long, it will suggest you to turn that off, or to save your money, like to save on billing. It can recommend you to switch to a lower version of it. Then there is live migration. So while shifting to a higher or a lower, whatever, it can be computing power, storage. So you don't need to turn it off actually in some cases. There can be live migration done. So let's say your VM is running, you can just increase the disk space or you can just increase the RAM in between. You don't have to turn off the VM. Yeah, and you sometimes do get discounts in between. Um, it's not fixed and it depends on the offer or promotion. Okay, this is the pyramid of like serverless computing where this shows that what has to be managed by the user and what will be taken care by Google. So you can just see that, uh, as I said, GCP is more of a IaaS and PaaS. So they only provide infrastructure and like platform. So you have to develop your own application. As I said, like we made our application and we just hosted it on GCP. And yeah, performance monitoring has to be done by you. That am I using more than what I should use, or is my VM like is the application inside the VM running properly? Okay, and Google will take care of scaling. So whenever you need to scale, they will take care. If you need more VMs, they will provide you that as well. Then yeah, all the other basic securities and internet connectivity, as I showed in the previous slide, that all the cables that have been laid out. Then all the physical servers are kept in the GCP farm, so you don't even have to go there and see that what's happening. Okay, and yeah, this was pretty much it for the compute part. When we go with storage services, so GCP also provides some variety of storage services that you can use. So the three common uses are like first, it can be content storage and delivery. So when you open Instagram and you see there's a photo in the app, so where does it come from? It comes from like the nearest server of Instagram or like whatever backend they use, and that's called like content delivery. So there are some dedicated servers for that, which are called CDN, Content Delivery Network, and like that's their only job. So this is one use case for the storage. Second can be for the internal data analytics that the company needs to have, and yeah, for the other operational purpose. Then there's also backup and archival storage that you can use. Yeah, so any sort of like data is um, broken down into these two categories. So one is structured and one is unstructured. So structured, we have seen in the last semester for batch 2020 that there are these tables, there are columns and rows. And yeah, this is called like a relational database. And on the right side, you can see unstructured data. So it needs not to be of similar type. You can store any kind of data in that. So, but in the relational data structure, every data that you enter has to match the columns parameters that are there. So this is a common flowchart. I'll provide the slides after the end so you can have a look again. So what type of storages you will need? You can just go through this flowchart and just decide. So if your data is structured, so if it's not structured, you obviously have to go to cloud storage. Like this will fall under all the other types of files like photos and videos and all that. And if it is structured, and again, inside that you have like workload analytics. If it comes under that, you can see that there's one more parameter that do you need low latency or you're just fine with a normal latency. So if yes, then you can go with Cloud Bigtable. If no, you have to go with BigQuery. Then if it doesn't fall under workload analytics, and then you have to make a decision that is it relational or not. So if it's not, then the only option that you have is data store. And data store is actually now called the real-time database on Firebase. So this is actually the old term. Then, yeah, do you need to scale it horizontally? Now we were on is your data relational? So if yes, then if you have to scale it horizontally, you can search this up, like what horizontally scaling means. Uh, if yes, then you can go with Cloud Spanner. If no, you can go with Cloud SQL. And Cloud SQL, as I said, is like combination of 2 to 3 SQL databases. Coming on to like GCP, like security rules and IAM roles uh, in the platform. So for every project, there are like different set of people that can access it. So the first one in the hierarchy is an admin or the owner, the one who creates the project. He can access anything um, of the project, like he can delete any stuff, he can edit any stuff, he can add any stuff. Okay, now this actually does vary a bit on platform to platform. Uh, and yeah, on the top you have admin or the owner. Then next you have like editors or similar roles where the person is not an owner of the project, but he can edit anything else. Now, even under editor role, you can specify that what that editor can or cannot change. So let's say I've made a person one an editor for VM, like VM instances, and person two an editor for some other like a Kubernetes cluster. So they cannot do they cannot do anything apart from what they're supposed to do. So person one cannot edit anything from the Kubernetes cluster, or person two cannot edit anything from the VM instances. Then on the third, we have like viewer or similar roles. So these roles can only log into the platform and they can only see what the project consists of. They cannot change anything or delete anything. So basically, these there are like just three. So I'll go through them again. First is admin or owner, who owns the project. Second is editor, who can edit the specified parts of the project. Then third is viewer, who can only see and not edit anything. Okay, this was it. Like this was the whole module one and module two. Now, when you do the labs, you will get more practical experience on what to do. So tasks for this week. On the track one, you can do module one and module two. So module one is getting started and creating and managing cloud resources. Cloud two is you will perform more foundational infrastructure tasks. So yeah, thank you all for joining the session. If you have any quick doubts, you can ask me now. Yeah, sorry guys, there was a network issue from our side. You can ask any doubt or question if you have regarding the event or even quick labs. Yeah, Priyanshu. Okay, I'll just once share my screen and show you the quick labs website. Okay, so Nishant asks, can you tell how to access labs? So this is the quick labs profile that you would have made while registering the form. So you just have to head over to quicklabs.com and just keep this tab opened. And if you have already enrolled into the quests, you will see them here. If not, you have to go to the events website. I will share all the links that we've talked about in the message on WhatsApp group. So yeah, after going to this website, you can just scroll down and you'll get the program syllabus. Both the tracks are mentioned here, and all the 6 modules from the 2 tracks are mentioned. So let's say you want to start with the first one. You just open it in new tab, and there will be an enroll button over here. One second. Yeah, so if you have already enrolled, you will not get the enroll button. But if you have not, you'll get this button. And after clicking on it, you will be just enrolled into the quest and you can start doing the labs. Okay, every quest has the set of labs that you have to complete. And after completing uh, all the other labs, you will get a skill badge. So if I were to show, you can check all your badges on your public profile. Okay, now I have this skill badge. This is actually a quest badge, which I got after completing all the labs. And after you complete the challenge lab, you will get a skill badge. That's the only difference. In challenge lab, there will be some tasks that you have to do on your own based on the understanding that you have of, like based on what you've learned in the previous labs. So this will be a bit tricky, but all the other labs will be very well defined and in a structured way where you just have to read from quick labs and perform on GCP. So yeah, Priyanshu, you can start from, like, you can just go to this website, click on the modules, and yeah, again, make sure to sign in incognito mode. As I have only one account signed in, so it won't make much issue for me. Yeah, Sophia, you can find the modules on this website. Is there anyone who hasn't completed the 2 lab yet? Like, Yeah, Nishit asks, I don't know machine learning, so would I be able to follow track too? Yes, definitely. Like, you don't need to know about it to follow along, but even having a basic idea will help. So just having a basic idea of what machine learning is, you will know like what you will be doing in the labs. But like rest assured, you don't have to know it, because I'm also not an AI guy. I don't know much from AI or ML, but I can still make use of it. I can call APIs and like according to the need of my project. Yes, Shakit. I'll share all the links on the WhatsApp group, so no need to worry. Yes, so like this is all for today. So basically, like these sessions are only conducted to brief you off on the theory part of like whatever the module is about, and practical you have to do on your own. And like I will help you on like if you're stuck at any lab or even anywhere in the event. Yes, and you can start doing the labs from now. Actually, this program started on 27th of September. So any lab that you have done even after 27th or even after 24th will be counted. And just make sure that you complete all the labs anytime before 27th of October, because that's the program ending day. Okay, I'll end the meet at 5:25. So you can ask any questions if you want now or anytime on WhatsApp. I'll share all the links and all the necessary info on the WhatsApp group. So just make sure to join it. I'll link the WhatsApp group's invite link again. Okay, everyone, I'll just end the meet. Thanks for joining.